So this video is going to go through the 2019 section C3. It tells us the image on the right shows the Louis Vuitton retail store in Singapore. The design comprises a steel framed glass building with irregularly shaped faces. Figure C3 shows the elevation, plan and end view of a model of part of the building. A. Draw the given elevation, plan and end view. B. Determine the dihedral angle between surfaces A and B. C. Determine the true shape of the vertical surface C and the true shape of the inclined surface B. And then part D, determine the horizontal and vertical traces of surface B. So part A is fairly simple. Draw what we have here. Part B then asks us to determine the dihedral angle between surfaces A and B. So basically the line that's common between A and B, which is going to be this line here. You can see B is sloping back like that, and then A is sloping downwards, hence why the line on the ground you can't see it. But there's your line that's common between the two. So what we're going to have is an auxiliary going off out here first to get the true length, and then the second auxiliary somewhere out here as well, showing our dihedral angle. Part C then is determine the true shape of B and C. What I'm going to do here is use rebattement and take that and flip it out this way, and same with C here, take it and flip it out that way. So we're going to be keeping part C in this area of the page as well. And then for part D, determine the horizontal and vertical traces. We remember that a trace is a line where the plane that we're looking at intersects with the vertical and horizontal plane. In this case, this line here is on the ground, so technically if we look along that line there, that's going to give us our horizontal trace. And then we can take our second line along here, take a height up and across to get a point to give us our vertical trace. So that line's going to extend a good bit out here, so what I'm going to do is keep this drawn to the right hand side. There's nothing going above these views here, so I'm going to keep it nice and close to the top of the page to allow plenty of room for my dihedral angle below. It's going out here somewhere. So just to position the question, I'm going to take this point here as my starting point, and I'm going to use my widths here, which are the same here, to start it off, and then I'm going to start with the elevation then as a result. So for the height of it, I'm told my highest point is up 60. So for example, I could go down about 80 mil, say, for the top, or sorry, my XY line. So go down 80 mil, take a line across there, pick that point maybe as my starting point, and then I'm told my widths are going to be 25, 30, 20, and then a 10 mil gap between each view. So it's important that you include that 10 mil gap, so it's not just make it up whatever you want, the distance between your elevation and your plan and your elevation and your end view. So I go 25, 30, 20 and 10, and that point there now is this point here in my elevation, so I know where my elevation is now going to start. So for the widths of my elevation, I'm told they are 35, 25, 75 and 20. And then my height is going to be 60. Excuse me. And my first edge I'm going to have here is going to be that one there, and that's going to go all the way across to the end where that line connects to there, that line connects to there, and then given the height 35 in my end view, so for this height here you can see it's going up 35. So I could just mark off my 35 here if I want, take that across, and where it crosses that point there, that gives me my slope there. Now what I can then do is I can draw in heavy, and I know where that stops for surface C, and it also gives me the rest of surface B too. So there's surface B, there's surface C, and surface A is that surface there. For my plan, let me just take all these distances down. And then take these at 45 for from my end view in order to get my plan drawn in. So my 20 goes down to there, and then we have a line going in at an angle here, and then that extends on then to that point there, and that connects back to this point here, which I have to find now from my end view. Or no, if I just look at the question there, that line drops down there until it's 60 for that distance there, and I can go down 60 there, and where that 60 cuts across this line here. So I'll just show you again, that goes down there, and where my 60mm line goes across to meet it, that gives me a point on that line then. So that pink line there that's in the question gives me this line going back here as a result, and I can drop that down there. I can take that line there, and then I have this going down to here, joining back to there. So I just use a colour to show, just like in the question, at that point there is that line that you have. So the next thing I need to draw is my end view. Okay, so for the end view then, we already have all of our heights here. We can take them across, and this height there, and then we already have our widths here from setting up the question initially, and what we have as a result as well is we have these other points as well here that we found, the one for example here. So the end view then, we have our line going from there, and then we have it going all the way along the ground, and you can see there in the question as well, this height here we followed across is this point. So to make it easier for myself when I'm trying to solve it, I could just put the page down like that there, and what I can do is I can take all these across to see where they're hitting in my end view, and this point here, and then that means when I take them up at 45 I can see which points connect to where. So for example, I can see that this here is that point, I can see that that gives me that point there, that gives me that point there, and that gives me that sloping point there. And the last point then is this height here. If I follow that down and follow it across, it's basically on that line there as a result. So that line and that point are the same. So follow that one across, up and over, and I follow that across, up and over. I get this point here. It's then going to go down at that angle there, and then this line here connects up to there. That closes that off there, giving me surface A. When we're looking this way, we're going to see surface A there as a result. And then I have this point here, goes up and joins down to there, and then this is going to be hidden detail out to there, and my last line then to complete my end view is that line there. And there's my XY line now drawn in as well. So that's part A complete there. Part B then asks you to determine the dihedral angle. So we've determined that is the line there, and just as I see in the question, my hidden detail here. There's my line that's common between the two. So what I need to do first of all is get the true length of that for A and B, and then look perpendicular to that then, or look along it then to see a point view of it. So I'm looking at A and B. So I'm going to keep this view out a bit here, so I have room to draw my rebatment of my true shape of surface B. So there's my x1, y1, and as always we go 2 views back. So this point here is on the ground there, this point here is on the ground there. So I label them, for example, 1, 2, 3 and 4 for surface A. 1 and 2 are on the ground, so there's 1, there's 2, and 3 and 4 are up this height here. So there's 3, and there's 4. So 1 connects to 2, 2 connects to 3, 3 connects to 4, and then 4 connects back to 1 there. And there we have the true length of line of intersection there, that line. Then what I can do is I can label this as 5 and 6. So 5 we follow up, 5 is on the ground there, 6 we follow up is that height there. So I'll mark off 1, 2 there, and 3, 4 there as well, just to complete my labelling. So 5 is on the ground, there's 5 there, 6 is up this height here, follow it out, follow it down. So 1 connects to 5, 5 connects to 6, 6 connects to 4, and then 4 goes back to 1. Then we need to look along the line 1 and 4. see there's a point view. So this one might go slightly off the page here. There's point 3, point 2, point 5 and 6. And what I'll do is I'll try my best to move this line back to touch off 1 and 4 and create a measure line there, so I can try and shorten the amount of distances I have to go with this question. So for my second auxiliary then, if I just line that up there, and I'll just have my x to y2, I'll have it just touching off that there. So x2, y2, try to see if I can fit it as best I can on this. So 1 and 4 are touching off my measure line, so I follow 1 and 4 out, I have it there. 3 and 2 then, so I take the distance out to 2, follow it down, follow it out, oh, 2 is out here, so the distance 2 there, follow it down, follow it out, there's 2, and then 3 is that distance there, follow it down, follow it out, and this should form a straight line, which it does. So there's that surface as an edge view, and then 5 and 6, 5 there, follow it down, follow it out, so it's going just off the page there, and then 6, follow it down, follow it out, it goes off the page there. When I line them up, you can see they form a straight line, and just for that I'll just mark it like that there, and that gives me my dihedral angle there. So that's part B then complete. Part C then, determine the true shape of the vertical surface C and the true shape of the inclined surface B. So this is surface B here, and surface C is that one there. So I'm going to do is rebatment. So imagine, looked at this before, we have 2 hinges there, and what we're going to do is imagine that was surface B at an angle. We're going to rotate it out so it's sitting flat down so we can see the true shape of it. So I already have the true length of 1 to 5 there, because if you look at it, that line there is parallel to XY line, therefore that's going to be a true length as a result. So that's why I'm going to use that as my hinge point. So I'm going to extend out points 4 and 6 there, because I need to get the true length of those. So for the true length of 1 to 4, if you look at here already, we used it in our auxiliary view. We were looking at that as a line of intersection between surface A and B. That line is parallel to that, therefore that's a true length which is already determined. So I've already used that, so I can just take that and reuse it again. So from 1, where it hits it, the extended line going out, that gives me that side there. Then for 5 and 6, neither of these lines are parallel to XY line, so what I can do then is I can rebat them around to make one of them parallel. So for example, I have a line there going across for 5, I can take 6, rebat it down, and then take it up. The height of where 6 is there, join that back to 5, that's going to be my true length there for that line. And then from 5, you can swing it out there to that perpendicular line going out there, and that gives me true length of that. All I have to do then is connect those two together. That gives me true shape of B. And for C, I'm going to do the exact same thing again. I'm just going to use this line here, 5 to that point. So what I could do is label this as 7 and this is 8. 5 to 8 is on the XY line, therefore it's parallel to it, which means that from 5 here to 8 there, that's already a true length, and I'll use that as my hinge points and flip it out this way here. So I need to find 0.7 and 0.6. 0.6 is somewhere out here, 0.7 is somewhere out there, and what I can do is 5 to 6, I already have it. If I just mark it off there, there's 6, and I didn't mark off this point. I have 1 and 5 there, 6, 3 and 4, I have 0.4 here, just to finish off that. I already have the true length of 5 to 6, and what I can do is I can go from 5, swing it to where 6 is in that line. Now I have 0.6 there, I can join that back like that, and now I need to find 0.7. And once again you can see that 0.7 is there, it's going to be out here somewhere. Neither of these lines are parallel to the XY line, so what I can do is I can rotate one around to make it parallel. So for example, I can swing from 7, take 8 down like that, take 8 up there, join 8 back to 7, take that as my true length, and then from 8 here I can swing that to hit my line 7 there, and now I have the true shape of surface C. And that is part C then complete. So just between the two I can mark that there. And then part D, determine the horizontal and vertical trace of surface B. So we already discussed at the start of the question that a trace is basically a line where a plane meets the horizontal plane and the vertical plane. So for example, if this was a plane here, where it hits the table here, that's going to give you a line along the horizontal trace. This line here, 1 to 5, is on the ground, so therefore 1 to 5 here is the trace for surface B. So what I can do is, I'll just use a pen to show it, I can extend 1 to 5. All I need to do is extend this first, so I want to see where it intersects it. I can extend 1 to 5 like this here, and you see it's just going to go off the page ever so slightly. So I just extend that a bit more and just extend this here, and that's what's going to hit it, and that gives us our horizontal trace. What we can do then is we can extend any other point on surface B. So for example, we have 6 and 4. We line that up there, go to, for example, say 4. 4 hits it there. We take 4 straight up, 4 across, there's the height of it there, join that back, and let's use a red pen again, and that gives me my vertical trace. So it's basically looking at the oblique plane chapter for that. So hopefully that video helps anybody maybe stuck on that question.